After the last video on the cosmic microwave background radiation, Midori Fan 10 asked this question, and I want to do a whole video on it because it's a really good question. And he or she, I'm sorry, Midori Fan 10, I don't know whether you are he or she. If all this radiation is reaching us now, does that mean that there will be a point in time further in the future when there will be when there will no longer be any cosmic microwave background radiation because it has already passed us by, or does it not work like that? So let's think about it a little bit. Just as a review, what we're saying is if you go far as light from further and further away in the universe gets to us, we're actually looking not only at light that's traveled a long distance, but we're looking at light that left a point in space a long time ago. And so when we're looking at things at the edge of the observable universe, the photons that are reaching our eyes right here, they look like they're over here. We actually now know that those coordinates in space right now are much closer to 46 billion light years away, not 13.7 billion. But this diagram is done based on how long the light from that object has taken to get here. So when we look at light from this object here, not only are we seeing it from that point in space, but we're also seeing it from 13.7 billion years ago. Or we're seeing it from that point in time where we had just this hydrogen haze, this hydrogen plasma that was uniform all around. The universe hadn't started to become differentiated into stars and galaxies. It was all this one uniform plasma. And because of that, anytime we look at photons from that distance, photons that were emitted within 400,000 years of the beginning of the universe, they're just this uniformity from that distance. And that's what we call the cosmic background radiation. So the question is, if we wait a billion years, if we were to wait a billion years, the stuff that was emitting, the stuff that was a haze 13.7 billion years ago, if you go a billion years forward, it will no longer be a haze. It will have started to differentiate itself. So if we were to forward a billion years, it is true. The things that are 13.7, the photons that have taken 13.7 billion years to reach us a billion years from now, those won't be photons from that hydrogen plasma kind of white hot haze. Those will be photons from a more differentiated universe, from early stars, and it won't be uniform anymore. So you might say, oh, Midori Fan 10, maybe you're right. Maybe we're out of cosmic microwave background radiation. But you have to think about it. This is not the true boundary of the universe. There's more stuff out here. There's more stuff out here, outside of our current observable universe. Outside of observable universe, of our current observable universe. Outside of observable universe. And so a billion years from now, instead of talking about the photons that have taken 13.7 billion years to reach us, a billion years from now, in a billion years, 1 billion years, if I were to make this video a billion years from now, I would be talking about the photons that are taking us 14.7 billion years. 14.7 billion years to reach. And those photons aren't going to be from these type of objects there. They're going to be from stuff out here. Our observable universe will have grown. We will be able to observe more of the universe because more time would have been passed to get photons from further out. But those same photons from further out, a billion years from now, would still be going 14.7. They would have been emitted 14.7 billion years ago during that hydrogen plasma haze. So we would still have that background radiation. It would just be coming from a point further and further out. So hopefully that makes sense. And I want to make it very clear, and I stated this in the last video because this could be very confusing. When this radiation, this cosmic background radiation, this relic radiation that we're getting now, when that was emitted, the universe was much smaller. The universe was much smaller. And let's just say this part of the universe. This isn't the whole universe here. This was just the observable part. Let's say this whole observable part was like this. And the whole thing was this haze. This whole thing was a haze. But the only reason why only this part looks like a haze is because those photons are the ones that left 13.7 billion years ago. The stuff that over here, we're seeing a later stage in the development of the universe because those photons only left 6 billion years ago. The photons that left from here 13.7 billion years ago, when this was in that primitive state, in that hydrogen plasma state, those photons have passed us by a good bit ago. So hopefully that kind of gives you a better sense of what we talk about and why from every point in the universe, if you look out 13.7 billion years right now, you will see this cosmic background radiation because you will be observing photons that were emitted 13.7 billion years ago. And 13.7 billion years ago, the only radiation that was being emitted by this plasma hydrogen white hot fog or haze or whatever you want to call it. So hopefully that answers your question. We will not run out of cosmic microwave background radiation. Assuming, and in the extremely high probability that there's stuff out here, especially considering there could very well be a ton of stuff, out here. And I'll even tell you this. So one, the universe is, based on many models, far larger, far larger, almost unimaginably larger than this observable universe right over here. So in that case, we will never run out based on the argument we just had. And maybe even more bizarre reality is what a universe that is not that much larger, and I'll do a future video on a universe that might even be smaller than this. Because you could imagine, then you have these photons. Let's say this point right over here. This point over here, 13.7 billion years ago, when it was in that primitive state, it might have released some photons. Those photons passed us up a while ago. But if this was the extent of the universe, those photons would go to one end of the universe and then come back out of the other. And so that they would have another chance to pass us by again. And so if you think about it that way, even if there isn't a ton of stuff outside of here, we'd still have those same photons going one side of the universe and then coming out on the other side of the surface of our four-dimensional sphere, I guess is the best way to think about it, if that doesn't confuse you too much. But the simple answer is we will not run out of cosmic microwave background radiation. It should always be there.